Hello and welcome to this Chemistry World webinar, Making Strides in Sustainable Laboratories, Examples of Recent Initiatives. I'm Natalie Starkey, Chemistry World's science media producer, and I'm here with you for the next hour, where we'll be hearing from three speakers discussing how to reduce the environmental impact of chemistry research. I'll just point out that this webinar is recorded, so if you find that you miss anything today or just want to watch again, then look out in your inboxes for a link to the recording in the next few days. And if you want closed captions on for this webinar, then feel free to click the button at the bottom of your screen. Chemistry World are running this webinar in collaboration with the RSC Sustainable Labs team. Two of the speakers joining us today were recent recipients of the first round of the RSC Sustainable Labs grant, whose projects seek to answer questions in topics including areas like solvent choices and the reuse of single-use plastics. So we'll be hearing from some of them in just a minute. Now, the RSC Sustainable Laboratories grant is open for a second round this year. The grant aims to accelerate the chemical sciences community's journey to environmentally sustainable research and innovation. Grants of up to £10,000 are available for activities to advance understanding, increase take-up of environmentally sustainable laboratory practices in the chemical sciences, and facilitate sharing of best practice. If you'd like more information, then please email the funding team, but we'll also share details in the chat with their web pages where there's lots more information as well. Now, I don't want to take up too much of your time before handing over to our brilliant speakers today, but I wanted to let you know that as with all Chemistry World webinars, this session is interactive, which means you can ask questions about any aspect of what's covered in today's event. So please use the questions box to send in your questions as soon as they come to mind, and I'll be able to put those to our panel of guests in the live Q&A towards the end of the webinar. You won't usually be able to see other people's questions in the box, but don't worry, because myself and the Chemistry World webinars team can, so do start sending them in soon. We also have one of our colleagues who's working on the Sustainable Labs grant team in the background as well, so you might get a response directly from her with extra information. So please do send in those questions whenever you want. But without further ado, I'd like to welcome our speakers on screen today. So I'll just give them a minute to turn on their cameras so you can see who they are, and then I will introduce them. So there we go. We've got Martin, Christina and Helena. Brilliant. Thank you to all of you for joining us today. Just do a short intro. Right, we're going to hear first from Martin Farley. Now, Martin started as a technician and researcher. However, his interest in sustainability led him to take an alternate career path focused on making research and science more sustainable. Currently, Martin is the UK Research and Innovation Associate Director of Environmental Sustainability Programmes. And Martin actually founded the Laboratory Efficiency Assessment Framework, sometimes known as LEAF, at UCL. Following Martin, we're going to hear from Christina Picken, who is a postdoctoral research associate at the Sustainable Materials Innovation Hub at the University of Manchester. Her work focuses on the synthesis and testing of bio-based and degradable polymers for liquid formulations. She's got an undergraduate degree from the University of Reading and a PhD from UCL, and she's passionate about building sustainability into research and achieved the first Gold Leaf Lab Award at the University of Manchester. And then before we enter into the audience Q&A section of the webinar, we're going to hear from Helena Rapp Wright, who's a postdoctoral researcher at Imperial College London. Her research interests lie in analytical and environmental chemistry, mainly wastewater analysis, contaminants of emerging concern and sustainability. She's got a BSc from the University of La Laguna, an MRes from King's College London, and a PhD from Dublin City University. So I'm really excited to have these three speakers with us today. We've got lots to learn and lots to get through. So without further ado, I'm going to hand over to Martin to begin the proceedings, but please do remember to start sending in your questions for our speakers. So we're going to get Martin, his presentation up on screen, and then I will disappear for a minute once that's all showing. Brilliant. Thank you. Take it away.
Great. Thank you very much for that, Natalie. Greetings, folks. Martin Farley. I'll just kick off. So I wanted to set the scene a little bit in talking around sustainable laboratories. And I thought before looking forward, it's always good to look at where some of these things started. And I wanted to mention this fellow, Phil Wurdzek. Now, Phil Wurdzek sadly passed away just around 2 years ago now, but he was a former bench scientist at the Environmental Protection Agency in the US. And he realized something that a lot of other folks realized, which is that essentially that his work was quite resource intensive, and he started to have a think about it. And as far as I can tell, he really is one of the first people to have kicked off the Sustainable Labs movement, if not the first. He initiated something called I2SL, which is based in the US, but an organization that looks at sustainable laboratories around the world. And I think it's really great that, it makes sense that somebody that was considering the environment at the bench thought about what the impacts were beyond that. He inspired a lot of people, including a fellow named Alan Doyle, who was the one who got me started working around Sustainable Labs. Now, I wanted to also take a little step back, and this is a fun little thought experiment to think about what the full impact of the R&D sector could be on the environment. Now, this is very much an imprecise science, because what I'm about to show you on here is using a spend emission factor. That's essentially trying to convert a dollar of spend into carbon dioxide. But the idea of this little exercise was to give an idea of the impact of R&D as a sector. And this is, when we look in 2022, there was $2.5 million spent on R&D. Sorry, $1 trillion. And using a US spend emission factor, so converting that 2.5 trillion into carbon dioxide, gives you 390 megatons of CO2 equivalent. Now, again, this is not precise because we're not measuring the carbon. We're looking at spend, which is in an imprecise manner, but it's an accepted method, albeit it's not perfect. But using that methodology, we would see that 390 megatons is about the same as international aviation in 2021, which would make R&D the 17th largest country in terms of emissions of the world. Now, I don't think this is exactly right, but it does give you the scale of the sector that you're working in. Now, we talk about carbon a lot, but I just want to make sure that we don't just think about carbon. A lot around environmental sustainability is we convert carbon, everything into carbon as the metric, but actually there's a lot of important things to mention so the impact on the environment and biodiversity. And this is just something to think about the elements that are required, considering a lot of you might have a chemical background, a chemistry background. The one that I always think of in this is helium, which has under serious threat for less than 100 years and is used quite often as liquid helium for cooling of large magnets in a lot of equipment like MRIs and NMR. So this is a very serious topic. If we're going to continue our science, we have to think about the environmental sustainability of it moving forward. Now, I'm not going to go through all of these for the sake of time, but I think all of these are really important areas that affect, that we need consideration of as how we adapt to ensure that our research is environmentally sustainable and has longevity to it as well. I'm going to mention a few of these in particular, and one area that I'm going to focus on is one that Natalie set up well, and actually the subsequent speakers I know are going to speak on even better than me, but is on research. But I think all of these areas take a little bit of thought, and they're all going to have to adapt a bit to, well, the times and what's ahead of us. Now, from my stance, I work at UKRI, and we have a net zero policy for 2040, which is, as we're evaluating, is a led by science target. And we are working within the UK government, which commendably has a 2050 target. And we should acknowledge that a lot of public institutions and universities have net zero pledges as well. If you're interested to see if your institution has one, well, check your website. Or EAUC has a list of the pledges as well, and a lot of companies have these also. So what does this mean now for conducting research? How are we going to address some of this? Well, first of all, if you haven't heard of this, I'm guessing, well, a lot of people have, but in the UK, I think we're really at the forefront at a lot of this, and part of this is through the Concordat for Environmental Sustainability, which is being administered by the EAUC. And this is essentially a set of principles, priority areas that I've listed around how we address environmental sustainability as a sector. And it has funders and research institutions alike that are signing up to it. So if your institution has not signed up, I think this is a fantastic way to get some institutional direction potentially for addressing this topic. And I'll let you check out the website, but if you have any questions, you can get in touch with colleagues of ours, or welcome as well, or EAUC about this. But it's really setting the direction for this, and how we address it is going to be really interesting as a sector, I'd say. Now, what are we doing at UKRI? Well, we are working on a lot of things. One of which is integrating environmental sustainability. I've abbreviated it there a little bit into our infrastructure, which is really important for our net zero target. Our net zero target will focus on scopes 1 and 2 of emissions, and I'm not going to go into the background of scopes 1 and 2, but if you're not familiar with them, it's worth a quick look for reference. We will be updating our environmental sustainability strategy for 2025. The net zero target is embedded within our current strategy, and that is due for renewal and updating in 2025. So that's something that we're just starting now as a team. Now, something I think quite interesting that we've done is we've recently completed a Scope 3 analysis of UKRI activities, and it's not a public exercise, but I wanted to mention it because looking forward to our Scope 3 emissions, I'm skipping ahead, but we are starting to look at what we can do around internally as an organization now for our business travel. Keep in mind that at UKRI, we have a lot of institutes as well as funding operations. But we also want to look at what we can do around our supply chain and potentially our funding streams as well. And it's early days in this space, but it's something that we are excited to look into what might be feasible. Within our own emissions as an organization, we are looking at our scopes 1 and 2 of our own institutes. And something that we're just, I think, quite close to passing would be a carbon budget for scopes 1 and 2 of our own operations, which is a really interesting exercise, I have to say, to be undergoing. Carbon budget is really great because while you as an organization, you might have a net zero target for 2040 or earlier, carbon budget allows you interim targets to really focus the attention on what's needed at sooner time points. Around procurement, I just wanted to mention, this is from the NHS, but I think it's a great example of what we could be doing as a sector and something that we might look to, which is around getting our suppliers and using a common language on them. The reason I'm mentioning procurement is that supply chain activities is really one of, if not typically the largest impact we have on emissions. It's all the stuff that we purchase. And by putting common requirements on our suppliers, it's really how I think we move the needle in a common direction towards full environmental improvements, and not just looking at our scopes 1 and 2 of our emissions, so our energy consumption on site. Now, if you're interested more what you can do at your institution, I would really encourage you to have a look at this RSC published article. The lead author was Thomas Fries, and this is a fantastic case study, not just case study, it's a full review of the topic of sustainable laboratories. And it references a lot of what's been done at Groningen, which is in the Netherlands. And, it's got Ben Feringa, Nobel Prize winner, as a last author. And I'm not going to go through this paper now for the sake of time, but I think it really serves as it's a recent publication, as you can see, 2024, and it should inspire on what could be feasible at your institutions, and it covers a breadth of activities. And actually, the other thing I wanted to mention, and Natalie's mentioned, is just that if you're interested, we need more enabling research in this space. So the grant on the left there, the MRC one is closed. And actually, before joining UKRI, I had applied for that. But actually, NIHR has launched some larger calls for environmental sustainability within healthcare and clinical spaces. And of course, Natalie mentioned the Sustainable Laboratories grants from the RSC. I can't recommend these enough. And I really think I just have to say, and I know that she's promoted them, but I can't say how fantastic of an initiative I really think this is. So many times people have come with wanting to test ideas, but it takes a bit of resource to be able to test them. And I think grants like this are what allow people to see what's feasible in this space. And I'd really recommend, if you're interested, to consider applying for one of these, because I think you can get some due credit as well, and to test something. And that's, a lot of these things can snowball to see, how some greater impacts can be had across the sector. So in terms of research, I would really recommend that. Before I joined UKRI, I was involved in some of this. This is a life cycle assessment we did for the carbon footprint of single-use lab consumables. Just to reference, I think this is, I'm, I guess, blowing my own horn, but it's yes, I thought this work is beneficial, and I think the cases you're going to hear are also quite beneficial. On a slight left field example, I just wanted to highlight that sustainability laboratories isn't just always what we do in terms of the outcomes of the research and how the laboratories is run, but to also give some thought about the ecosystem of science. So considering, this is a holistic approach, and no single individual can fix this. So it's not, or address this, I should say, but I just wanted to highlight considerations for the volume of publications, highlighting not just your publication totals, but your other skills. And that's a UKRI reference about trying to push more narrative CVs for the value that you bring to science. I would really encourage you to check out some of the resources UKRI has around building a stronger narrative around this space. A lot of sustainable lab organizations out there, please check them out. I'm going to reference them there, but there's a lot that we can do in this sector. And I know it feels quite daunting, but I would just say each person can focus on their little slice of pie. So we can each do only so much in the face of it all. And I'm going to stop there because I'm at time. But thank you very much to our organizers. Thank you for listening. And I really look forward to the next two talks.
Oh, thank you so much, Martin. That was brilliant. A great introduction to the topic. And we've got a brilliant audience today. Lots of people in the session and lots of questions coming in. A really quick question for you before we move on to the next speaker. It was basically, how can we determine if net zero targets are realistic or feasible? And that's a great question, because it seems like a lot of hand waving, a lot of back of envelope calculations. That's a great question. How can we determine that?
I think the best way is to assess if they're accompanied by or led by a plan. So I think it's really important to set targets and aspirational ones to motivate organizations, but I think just as important are the subsequent plans of how we're going to get there. So really, getting into the details of looking at your state, what's within the boundary of your net zero plan. What do you mean by net zero? Is it actually zero emissions, or what are you allowing within that? So it's really getting into the details. So setting the targets is really important, but having a strong, ideally public plan. And actually, that's one of the recommendations that the Sustainable Supplier Roadmap from the NHS puts on suppliers, is having carbon reduction plans in the public domain. I don't want to go on too long on that topic, but happy to take questions if anybody wants to drop me an email about that.
Brilliant. Thank you so much. Right, well, we'll come back. If you've got more questions for Martin, please send them in. We'll be coming back at the end once we've listened to the other two speakers. But let's get Christina up on screen now and get her presentation shared, and then we'll come back to our panel at the end. Hi, Christina. Right, we'll get your presentation up, and I'll let you know when I can see it. Brilliant.
Is that all good?
Okay. Yeah, that's all good. I'll leave it to you. Thank you.
Fabulous, thank you. I'm going to be talking about a project that we've kind of focuses on sustainable solvent alternatives for gel permeation chromatography. And as chemists, we use solvents for a variety of different reasons. That can be cleaning, sterilizing, running chemical reactions, dissolving or isolating particular compounds, as well as within a variety of different analytical tools. And this combined is estimated to be about 20 million tonnes worth of solvents per year, which is a big problem when you think about a lot of those solvents being kind of categorized as unsustainable. So when we think about sustainable solvents, sometimes known as green solvents, we can think of these in a variety of different ways. So we can think about whether or not they're derived from renewable sources, whether they're biodegradable, if they've got a reduced carbon footprint, but also whether they've got lower toxicity or if they're non-flammable. We can also think about whether or not they've got something like a high solubility power, which means that you use less of the solvent, or if you've got high selectivity with a particular solvent, which allows you to reduce the impact of other parameters, such as being able to run the reaction at a lower temperature or for a shorter time. And so there's a variety of different ways to think about these. And so GlaxoSmithKline put together a solvent sustainability guide a while ago and have recently updated it. And essentially they use what they call a G score, a greenness score, which is a composite of the waste, environment, health and safety impacts, and essentially plot them on a scale going from a green, either a green where it has fewer issues or a red solvent which has major issues. And so the general advice is to avoid red solvents and use green or yellow alternatives if possible. Now, I'm based at the Sustainable Materials Innovation Hub, and we are looking at sustainable polymers or polymeric materials. And so as part of this, we might be looking at the recycling, whether that's by mechanical or chemical means, which allow us to then either reprocess or repolymerize into other high-value materials. And as part of this, we need to characterize whether or not we've got polymer chains of the same length, whether or not we've made them shorter, made them longer, or invoked cross-linking events. And one of the key mechanisms or methods we use for this characterization is something known as gel permeation chromatography, which in biological fields is sometimes known as size exclusion chromatography. And essentially what this is a machine in which you dissolve a polymer, in a solvent, and then you push that through a solvent-filled column, which contains these porous packing materials. And this interaction essentially separates your polymers by size, and then can track the elution time, so how long the polymer is in the column, to the molecular weight. So this is essentially detected as it leaves the column by either refractive index, light scattering, or viscometry, to name a few. And like I say, we then track the elution time with the molecular weight. And so we're able to work out what the size of the polymer is and how dispersed that polymer population is as well. And one of the kind of common solvents for this is known as dimethylformamide, known as DMF. And that's because it's an excellent solvent at dissolving polar aprotic polymers. It has a high boiling point, and of course, it's incredibly low cost. But this isn't without its hazards. It's also derived from fossil fuels, and it's undergoing increasing restrictions in Europe at least. And so we wanted to understand if there are alternatives to DMF as a GPC solvent. And so we've conducted a critical review to compare the sustainable solvent options in the literature. We've looked at the solubility and the stability of different polymers in solvent, and then validated these using GPC. And so we're right at the kind of cusp of a point where we're able to publish our findings. But it's worth noting that it's not just sustainability that's going to make or influence people's decisions on what solvent they use. Safety is always going to be a key feature, as well as cost as well. So from our literature review, we found that there are about 5 different solvents that are kind of viable alternatives to DMF in a variety of different reactions. So we've looked at dimethyl sulfoxide, known as DMSO, anisole, styrene, gamma-valerolactone, and 1,3-dimethyl-2-imidazole lidenone, known as DMI. And so they all have relatively high boiling points, but you can see when it comes to the cost, the top 3 are in the double digits, whereas the bottom 3 are now in the triple digits. So there is a huge cost influence into which of these is going to be kind of a viable alternative. And then there's other parameters such as polarity, solubility parameters, as well as viscosity. So here you can see that some of the solvents have a lower viscosity than DMF, but others, such as DMSO, have a viscosity of almost double. And so we've analysed a variety of different polymers just to assess their solubility within these solvents. So we've taken 3 polymers that are common calibration polymers, some what we've termed common polymers. So these are polymers that are utilised in a variety of different labs, whether that's research or industry, and focusing on polymers that are going to be of increasing interest as we move to more sustainable polymeric materials as well. And then our last category are known as challenge polymers, and those are polymers which are not necessarily common, but they are of relevance to the work going on within our labs. And so you can see on the left-hand column, DMF has a pretty good solubility. DMSO was restricted in its solubility of, or solubilizing of, some of the calibration polymers, and anisole was able to dissolve all of the calibration solvents, but not the challenge polymers. Now, with DMSO and anisole being our most kind of viable from a cost-effective point of view solvents, we wanted to see if we could kind of exploit the solubilizing potential of DMSO and anisole by combining them in a 1-to-1 mixture, which you can see in the right-hand column. And so these were able to dissolve 2 of the 3 calibration polymers and all of the challenge polymers as well. So these are the 2 that we carried forward for our GPC tests. And so, like I said, so in this trace, if we just look at the far left trace, you can see that each peak is a different population of polymer, and each of those peaks and each of those populations correspond to a specific retention time and a specific log value, so a molecular weight value. And so from this, we can then use known standards of polymers of known molecular weight to create a calibration curve. And we've been able to create those calibration curves for both anisole and the 1-to-1 anisole DMSO mixture. So we're at a point now where we've analysed all of our kind of screening polymers, so our common polymers and our challenge polymers. And what we're really looking for is to compare each polymer in each of the different solvent systems that we've attempted to see whether or not we're getting a measurable signal, whether we're getting uniform peaks and avoiding any tailing of those peaks, and also whether or not we've got consistent molecular weight calculations for each polymer, regardless of which solvent system it's being analysed in. But what's interesting, and something that perhaps we didn't quite anticipate, is that in order to run these sustainable solvents, we're encountering higher viscosities, and so that's resulting in a higher increase in temperature in order to reduce the back pressure in the system. We're running for longer retention times, which means that we're actually using more solvent per sample, and because of these higher pressures, we're sometimes using lower flow rates as well, which is reducing our resolution. And so I think it's quite important that we think of these or sustainability in a more holistic manner, where we're talking about what solvent, where is that solvent coming from, what's the health implications, all of those components of the G-score, but also that of the system as well. Because if we're running at higher temperatures for longer times, and using more of that solvent, it's a bit of a trade-off between the sustainability between those 2. And so we've conducted this critical review and assessed the solubility and stability, although I didn't show the stability data today. And we're showing good compatibility of the anisole-based solvents in the GPC systems, but we just need to kind of quantitatively compare the suitability of these GPC solvents for the different polymers, and then also find a way to assess the broader sustainability metrics of using these green solvents, like I explained. So I really just want to say thank you to Yu Chen and Dr. Mo Jamali, who have conducted most of this work and have been great teammates on this. And of course, to the Royal Society of Chemistry for funding this project through the Sustainable Labs grant, and our university and lab. And thank you very much.
That was brilliant. Thank you, Christina. It's so lovely to see that you've been able to do this project and actually you're finding out some really interesting results. And I love that, it's thrown up new questions as well, which I guess is something you're going to need to investigate a bit further, and nothing's ever that simple, but actually now we're getting people thinking about how we're going to make these changes and what are the right changes to make. I just want to point out to the audience, there's been a really wide range of projects funded from the first grant of the Sustainable Labs grant, which was last year. The link is in the chat. We might be able to share that again in case you've joined after that was shared. It will take you to a PDF that will show you all the projects that were funded. So it might inspire you, because actually, we're only being able to show 2 of those projects today, just to get your mind sparked a little bit. But, there's so many different projects you can think about doing, and many more besides. I'm sure lots of people in the audience are going to have even more ideas. So do have a look through that list, because I think it's really interesting to see what everyone's working on. Christina, a quick question for you. How easy or hard was the kind of application process? I guess that's always something that puts people off, because I think, is this going to be a huge amount of work for me to do? Obviously, the deadline's in less than a month. So yeah, how, compared to other grants you've applied for?
It's incredibly easy. It's only a couple of pages. And I think a lot of people working in the lab are really quite close up with the problems they face. So it really is just a case of noticing something that you can see could be optimized, or maybe have had an idea for a wee while, and just popping that down onto paper. I can't imagine, I don't remember if it was any more than just a couple of pages.
Okay. So yeah, not too big, not like a massive grant application where you
not at all.
Months. Okay, that's good to hear. Okay, well, thank you so much. We're going to get you back at the end. We've got lots of questions coming in. I think some of them are relevant to your work as well. So we'll come back to those at the end, and I think we'll get Helena on screen now with her presentation, and then we'll come back to you in a minute, Christina. Thank you. Hi, Helena. Right, let's get your screen shared, and I'll let you know when I can see your presentation. Perfect, full screen, and you're ready to go. Brilliant, thanks.
Thank you. Well, my name is Helena, and today I'll be talking about single-use plastic and see if we can actually reuse it. So, as you probably know, plastic pollution is one of the highest sources of contamination, and this is mainly because it doesn't degrade, and also because we use it quite a lot for everything. It's not only posing a threat to the environment, but also human health. And I think now it's quite common to see loads of different news about plastics, like this one there that I put of the plastic fibers in tap water. But if it comes to our own experience, if we work in the lab, we actually use quite a lot. And typically we incinerate it after, because we're handling like chemicals and hazardous substances, so it needs to be incinerated. So the impact is actually quite high. And there's a study that estimated that in 2014, over 5 million tons of plastic waste were actually disposed, which you can see that is quite a lot. And I assume now in the past few years, probably has even been increasing a little bit. So this is actually a big challenge for us, and I work in an environmental monitoring lab. So as you can see, we have loads of samples because we need to cover like a big spatial and temporal analysis. So the waste that we generate of plastic is quite big, unfortunately, and most of it is because we need maybe sterile or single-use plastic, because you need to avoid cross-contamination between samples. You need to make sure that your experiments are accurate, are reproducible, and that's why all of these single plastic consumables. So I have here on the left, on the corner, a little example of some plastics that we're using in a big project we have at the moment. So this project, we're monitoring wastewater across the whole UK. So as you can imagine, we have loads of samples coming in all the time. And we use loads of different plastics. For example, just to collect the samples, we have Nalgene bottles, so little plastic bottles per sample. Then you might use a pipette tip to transfer to the centrifuge tube. to perform your sample preparation, for example, if you're not using like SP cartridges or something else, then we usually filter the sample before it goes to the instrument. So again, you need to transfer and more plastic, and then transfer again into a little vial, and then to perform your analysis, depending on what's your method. So this is a brief example of the method we're using at the moment for this big project. So we're getting approximately 800 samples a month, and we use a minimum of 2 tips, just talking about pipette tips because we all use it, per sample. So we're saying that at least 20,000 tips are being used per year, which is quite a lot. So for this project, we just wanted to see if we were able to reuse some of this single-use plastic, but plastic that maybe was common between different labs, to see if our experience can help also other people. So how are we going to do this? So this is a little bit of what I'm going to talk about now. So I'm going to go one by one in the next few slides. So the first thing is, who is going to do this project? And we thought that it would be a really good idea to do it with a work placement, get someone really young and get them intrigued and give them the knowledge of sustainability, because we think that maybe it's now that we should teach people when they come really young and when they start, so it comes to a day-to-day basis thinking, not something that we're thinking now that we should have done, but it comes regularly. So this was done by the help of Amber, who is the QI of the study, and we chose the T-level science program. So this is a program from the government that gives over 300 hours for a student to mainly give them like practical experience in the lab. So this is mainly for like a technical part of it. So we also wanted to design something so the student not only has the technical ability, but also a little bit of research, and can have also the opportunity to see if they like it and they want to pursue maybe research further. So we thought that having a project on sustainability would be the basis of the placement, and it turned out really great. And actually the students that we got really enjoyed it, and they went on to apply now for the Imperial College Apprenticeship Scheme, because they want to stay in the technical route, but also with a little bit of research and across the different departments. So we needed to design for the project something that was simple, so they could help us, and also to make sure that if we reuse this single plastic, it actually works for us. So we decided to do it by carryover analysis. So we wanted to test if we were, after exposing, for example, the tips to certain chemicals, to see if we could find them after, because if we find them, then it means that we can reuse them for our next sample, because we would be contaminating the next sample. So we selected single-use plastics that were in the lab, like you can see here, plastic tips, centrifuge tubes, and Nalgene bottles, mainly because we use one per sample to collect them. And mainly all of the plastic is it's made of polypropylene or polyethylene, but they all have different additives. And for example, even the different tips between them, there would be a completely different additive added to it. So we needed to test the experiment into all of the different ones to make sure that it works for all of them. And I'm going to talk about today just about the pipette tips, because I think that that's probably something that everybody uses in a lab, and also because of the time of the presentation. So the process was quite simple. We subjected the pipette tip to a solution. Let me put the laser point if I can. There you go. So we subjected here the pipette tip to a solution containing loads of different contaminants of concern, so chemicals that we're testing in the real samples. And then we wash it with a solvent. We throw away into the waste the solvent, and then we took some water to analyze it. And then we were able to see if there was any residue left in that water coming from the chemicals. And we did this by LCMS, and also some further analysis that I'm going to touch in the next few slides. For the method, we use one that we already developed in the lab, and we selected 135 different chemicals, mainly pharmaceuticals and illicit drugs, because these are the type of chemicals that most of the labs will use, so it will be more helpful with all the teams in the department and also with other labs. So the first thing that we needed to do was to select what solvents we wanted to, and I think Christina put something actually quite similar to this, so I'm going to touch briefly on it. We based it on the Chem 25 selection guide, and we wanted solvents that were first really common, so we could access them in the lab really easily. We wanted to try different ones, so I put family there because we wanted to try alcohols, ketones, esters, because we have quite a big broad range of chemicals. We have over 100, so not all of them will work with one solvent. So that's why we wanted to try different families. And also about the score. So as you can see here, there's a ranking. So the lowest score will be for the recommended, and it's mainly based on the safety, also the health, so the human health impact, and also the environmental score. And then it will tell you if it's recommended or not. So based on that, we selected 11 solvents, and as you can see, they are there in little boxes, and some of them that we selected are not included in this guide. For example, nitric acid, and we selected it because even that it's an acid, it's quite common to use for microplastic analysis to clean the consumables and everything in the lab, so it doesn't give you any contamination. And we also wanted to test a mixture, so we mixed ethanol and water because they were water is basically the best one, so it's a more sustainable one, the greenest one. And also water might not remove all of the contamination from the chemicals, so if we add an alcohol that is also quite good, like ethanol in this case is recommended, then it might help that water to remove those contaminants and still be low regarding the environmental impact of washing those tips. So we did an initial test here, and this was done for the normal blue pipette tips that you see in the lab. And as you can see here, most of the compounds were removed. These are the numbers that were still detected. So the best one was acetonitrile that only had 2 compounds left out of the 135. And the worst one in this case was IPA with 74. Regarding the peak area reduction, so not only what is left, but also how much, we saw that all of them were actually removing quite a lot of the compounds. So those areas, we tested it for 5 different concentrations, and we based those in previous real samples from the project, and it ranged from 500 nanograms per liter to 15,000. And we saw that most of them were reducing. Of course, the higher the concentration, the less reduction would be, which is why you have here, for example, big standard deviations with acetonitrile. And that was an example where you can see a QC at 500, and then the removal using 1 wash of acetonitrile. And as you can see, the areas are really, really similar. This is a blank that has nothing, so nothing was removed for that compound at that concentration. So based on this, on the reduction and also the number of compounds left, we selected 6 solvents to continue doing some analysis. We wanted to try different washes because you can see that with one we couldn't remove all of them. So here is an example of the different 6 solvents, and as you can see, the number of compounds actually reduced by wash, which is quite promising. We did have one here exception, which was for nicotine, and it came, so it was fully removed in wash 3 and it came back again in wash 4, and we think it's probably because certain compounds might actually stick on the plastic and then being removed again. So we needed to do a little bit of more investigation on this. So we do all agree that we need to increase the number of washes to improve that carryover, to remove all of those compounds. But the more we use the solvent, are we actually being sustainable? Is this actually worth it, all the hassle? So this is where we started calculating the impact, so how green the method of wash was. And for that, we use AgriPrep calculator. This is a calculator that gives you a metric for sample preparation. So we needed to adapt this because we're not doing sample preparation, we're just doing a wash for some tips. So we selected 10 criteria, mainly for waste, the type of solvent, and then we did a score system from 0 to 1 as per the calculator. And 1 is being the best. And I just have here 2 brief examples. So you can see that for wash 1, you have, for example, 0.48. And the more washes you use, the less sustainable it's going to be because you're using more solvent. And also you can compare solvents. For example, acetonitrile, the number is lower, so it's less sustainable than using nitric acid. And this is because, for example, nitric acid, even if that is an acid, we're only using 1% in an aqueous solution. So water is the main component, and therefore that's giving a higher sustainability score. So based on the AgriPrep ranking that we perform and the number of compounds that you are still seeing, so they are not being removed, and also how much of those big areas are being reduced after the wash, we selected 4 solvents for further analysis. And I'm just going to give you here a couple of examples for those 4 washes. You have 3 different compounds here, and you can see, for example, diclofenac. For all of those concentrations, you can see that in wash 1 you are basically removing the whole compound. However, maybe for silasapril, in this case you can see that the highest concentration, which is 15,000, is still not being removed. However, the other concentrations, for example the lowest one, you can see that it's been removed only with 1 wash. And that varies depending on the solvent. Some of them might work better than other ones. So, as I said before, different tips contain different additives. So after all, it's a different type of plastic. So we wanted to test with different ones. And this is just a brief example of a yellow tip, which is a P200 that you might have in the lab. And also positive displacements, because they have the little filter inside, which is also another type of plastic. And you can see the differences. For example, this one here, acetone, doesn't remove really well the number of compounds, while here, for example, those compounds have been quite reduced. But I did mention before that this is all done in ultra pure water, and our method is actually in wastewater. So when you add a matrix, it might have a big impact. So we did a test as well using wastewater, and here are only brief examples that you can see that the number of compounds are actually being increased by using wastewater, and that could be because it's already in the sample, and also because that matrix is playing a bit of impact within the plastic as well. And we saw that a higher number, but 38 of them were actually in common with the UP water, but also they behave, the solvents, slightly different. As you can see here, acetone didn't remove that many as, for example, compared in ultra pure water. Finally, we don't only need to see that all the compounds are removed. For example, we're basing it in pipette tips, so you need to make sure that you are adding the right amount. That's why we use them in the lab. So for that, we needed to test the degradation of the tip after the washes. And we use a pipette calibration test, so we using different pipettes and also different analysts, not to be biased. And this is just a quick example of using one pipette tip with this solvent tested ethanol and water. And you can see in green from the 3 different tests that the greens are the ones that passed using this criteria. So at small volumes like 0.2, you can see that they pass the criteria, but as soon as you start with a aliquot in a higher volume, you start having 2/3 passing only. So now we're putting together all of these results in order to see the different tips and the different solvents, and check that after you wash it, it does dispense the amount that you actually need to be accurate in the lab. And we also performed some standard microscopy on them just before and after the washes to make sure that the plastic is still okay and hasn't degraded. As you can see, it's 200 microns, so it's quite high. And now we're moving into an SEM to perform further analysis into a deeper level. So to conclude, The T-level experience was really good overall. You can see here Yasir just showing some results to the department, and he actually said that the best part of the whole work experience was the sustainability project, because he learned a lot about the research, presenting studies, making sure what the numbers mean, and putting graphs together and things like that. So overall, it was a really good experience. And regarding our project, we managed to test the carryover of over 100 compounds, chemicals in pipette tips for different ones. We selected now the 4 best ones, based not only on the AgriPrep calculator, but also on the amount that is being reduced and the compounds that are still left behind. We are currently putting together all of the information for the pipette degradation tips, and also for the surface, we're doing some SEM analysis. And for future work, we're now, once we have all of this info together, we'll select the best method, and we'll perform some life cycle assessment to see how many times you can actually reuse it, and also compare to incinerated them and see what is best after using that much solvent. And we're also doing this for other type of plastics like centrifuge tubes and Nalgene bottles. And lastly, I just wanted to thank everybody that was involved in the project. Of course, the Harris Law Academy for working in us in the work experience program, and the RSC Sustainable Lab grant because of funding the project. So thank you.
Thank you so much. That was brilliant to see that you've involved students in those projects, and it's such careful work that's been done. I love that you've thought about this very carefully, obviously, which is brilliant. I did have a quick question about the time it takes. Like, that might be quite a factor for people. Obviously, they're wanting to take on sustainable practices, but is it going to mean that their lab processes, are they going to have to employ an extra person to do all this cleaning? Is that a factor you've considered?
Yes, that's a really good question, because it's something that why we try to design it as fast and simple as possible, so people can actually do it on a day-to-day basis, because if you're getting 800 samples a month, you're not going to be probably cleaning every day that many tips. So yeah, it's not mainly because of the money that you save. We are doing it for the environment, so we don't mind spending a little bit of time on cleaning them. But we also, that's why we tested different compounds with different washes. So for example, we want to publish all this work. So if someone is only doing one compound with one set of tips, they can access the data, and they might only have to do one wash. So it will be quite quick for them. So it's only when, of course, you complicate it more, it complicates a little bit. But just washing takes like per tip, like less than a minute, because you just wash like this and then we leave them drying, and then they are ready to use. Yeah.
Okay.
And it's cheaper than buying equipment that can clean them for you.
Yeah. And there's a brilliant question related to, I don't expect you to necessarily answer this, but someone's commented that actually, the next step might be working more closely with the manufacturers of these products to see if there's better plastics that they could be using to actually work in sync with what you're trying to do in terms of how we approach the cleaning of these products. So that was great. Thank you. I can't remember who raised that now. I've just read it in the questions box. But yeah, that's another bigger approach to think about. Let's get the other 2 speakers back on screen, if we've still got Martin and Christina. I think Christina needs to run off. I think it was Christina needs to run off exactly on the hour. So if she disappears at any point, because I may run over a little bit with the questions, don't worry. She may just have to leave the session to move on to another meeting, but I'll try to keep everyone to time. So let me start with you first, Christina, seeing as we've got a little limited time. One question that's come in from Dan says, how much health and chemical safety did you consider when creating the database? They're saying that they've worked with DMSO, and it's got issues around pregnancy apparently. So that's quite an interesting question.
Yeah, so we found that both DMSO and anisole have limitations in, well, they're just not that safe for a variety of different reasons. If I remember correctly, DMI was a lot more safe, but then it comes at a much higher cost. And so it's just a balance. And I guess what we were willing to investigate was something that perhaps wasn't benign from a safety perspective, but something that might be affordable We will eventually look at some of the more kind of expensive solvents, but we just don't see that as a kind of drop-in alternative right now, and until those costs come down. So we did consider it, and we're aware of it, but there was nothing there that kind of ticked every box in terms of sustainability, safety, and cost.
Yeah, definitely. That's understandable. And again, we've got it's not a question from Robert, it's a comment, but it's quite a good one. They've been doing some similar work to you, looking at changing solvents, and they're actually finding, a bit like you've mentioned, the more green alternatives are much more viscous. So they've also struggled to get viscosity values though with these solvents. So is that something you've had a bit of a problem with, and you've kind of discovered it later down the line?
For a lot of the solvents, the viscosity numbers are kind of published or available. But yeah, we have noticed that there are limitations in the system, but you don't know how it interacts with the column. So I guess it might be worth a conversation, because I guess if we're using slightly different columns, we might be getting slightly different resistances within those systems.
Yeah.
But yeah, I mean, that's, again, it's one of those, we can narrow it down to kind of the solvents that we want to test, but until you put them through the column, you don't know whether or not those kind of viscosity issues kind of raise their heads.
Excellent. Okay, well, that sounds like, yeah, Robert, if you want to get in touch with Christina, I think all her details are going to be online anyway. So yeah, do that sounds like an interesting thing to look at. Let's move on. Let's try and keep it quick if we can, because we are quite limited on time. But to Martin, and I've got a really quick question about, from Rodak, asking about can you give a summary of the leaf scoring system? So not much detail, but if you can kind of give us a little bit of a summary of how you score that.
Well, it's up to you a bit. I think you have to, it's a qualitative approach. So it's hard to answer that, but you have to just see what people have done and try to see if they've, in terms of overall score, you have to, take on whether it's their first year, if they're starting, if they've just started, you give them a little bit more leeway. If if it's their second year, you be a bit more stringent. So, it's up to you a bit, and look for training within your institution. I'll leave it at that for the sake of time.
Okay, thank you. That's brilliant. Okay, let's have a look. Quite a general question. Now, it's not something we've really covered today, but chemists are always using fume hoods, and the questions is, oh, sorry, it's just asked me a question about my microphone. Let me just see why this is popping up. No, I don't want to do that. Hopefully everyone can still hear me. I don't know what the question was asking me on the software, sorry. But yes, asking about, fume hoods. And I guess this is looking at, more things within our laboratories about, can we just make simple changes about, just shutting things down overnight? But are there problems there? Are we, so I'm back. I'm not sure what happened there. The software was playing some gremlins with me. We're thinking about more general things. Obviously, we've looked at two very specific projects here. But yeah, are you in your labs? Are we thinking about bigger things as well? Are we, you've got these grants for these brilliant projects you're doing, very specific. What else can we be doing quite simply to be making some changes across labs that we're all using? And that's to anybody. I'll let anybody jump in and take that question. I know Christina's got a couple minutes left, so if you want to start, I don't even have anything to add.
Sorry, I didn't mean to. I'll very quickly, then Christina, go ahead. You can, yes, out of hours, you can let your BMS or whoever manages the system know that if you're going out of hours, if there are, particularly for teaching labs, you can try to reduce air changes in spaces. You can also try to make sure that there's caps for your extraction rates for your fume cupboards. Often they just get set higher and higher and higher over time. If they're VAV fume cupboards, it's basically the safest thing to do is just shut the sash. That's at a user level, but I think there's a lot more that you can do in terms of, coming to a collective agreement around reducing air changes overnight and capping extraction rates when they come to do that annual cost inspection. Stop there.
Okay, brilliant. Anyone have anything to add? That seemed to be quite a good answer to me.
Just before I go, I think that there is kind of hotspot areas around water usage, around energy with ventilation, with energy of leaving things on overnight. And I think the LEAF framework kind of captures most of those aspects pretty well. I guess I can speak for myself, and I wonder if this is true for Helena too. We've been kind of pushing kind of sustainable initiatives in our labs, well, in my lab at least, for a wee while, and we've kind of done the kind of recommended kind of implementations. But then there's the kind of, well, what next? How do we improve what we do beyond LEAF and beyond what's published and beyond what's recommended? And I think that's where the RSC grant comes in really well, because it kind of helps us enable how to answer some of those questions. So yeah.
Absolutely, thank you. Helena, I've got a question. It's an interesting one. Have you tried soap to wash your pipette tips? And if so, would you recommend it based on your analysis? That's a good one.
Yes, you said soap, right?
Yes, soap.
We haven't, because we think that might leave something that will interact later when we get our samples. So just to avoid contamination, we haven't. We are going to test a dishwasher for bigger things like bottles, because of course, little tips and stuff, you just want to do it manually. It's a lot quicker. But when we want to recycle bottles, we are washing them at the moment with the dishwasher, and that contains some salt and soap as well. And we haven't had any problems so far regarding our chemicals. But if you're doing certain biological analysis or something, then I guess you'll have to try and for your own project itself. But yeah, it's not for the tips. We haven't done that. We are just using solvent, because it's mainly what you will use anyway in the lab to clean other things for chemicals, like even glassware. When you make a solution or something, you will just use some solvents to wash it. So that's why we're using that.
Yeah, and I suppose, I mean, I'm just thinking back to my PhD days where I did a lot of glassware washing, and I think it was that the thing, when you're using glass, it maybe is more washable than the plastics, and we just got used to these single-use plastics. We just throw them away. So, I mean, it was a horrible job. I absolutely hated having to sit for days, because once you'd used the lab, you then had to go back and do a lot of washing. And it felt horrible at the time. And it was the most boring thing to do. But, it was, I guess, a more sustainable approach, but it did use a lot of water and stuff. But yeah, for me, it was the time to sit there, but it had to be done.
Exactly.
As a PhD student, it was like your rite of passage to sit and clean glassware. But no, that's brilliant. So you're obviously thinking ahead to now cleaning bigger bits of plastic. So what's your next step for you once you've kind of looked at pipettes and you've mentioned kind of dishwashers and things? So is that kind of your next step?
Yeah, so we have now basically we're putting together all of the information to try to select only one method to make it a little bit simpler. And once we have one method, we'll move into other plastics. We've done initial tests with the dishwasher, and we did see that certain compounds actually are well removed after that, because some of the bottles have a really narrow neck. So it's hard for the dishwasher to clean it properly, let's say. So if you have a bigger one, I guess that's fine. But to improve sustainability, we're trying to move into smaller bottles, because then you need to store them. So we actually are collecting now all of our samples into really small bottles, which are harder to wash. So it's all a bit of a balance, I guess, on what you can do. And as part of the LEAF application, we actually try to move into glass with all of the things that we could. But of course, pipette tips and stuff, there is a bit of a challenge, and that's where it came up, the idea of like, what if we wash them? And also because during COVID times, it got quite hard to get pipette tips and certain plastics delivered. So we said like, if this happens again, it would be nice to even reuse it for, to have some extra in the lab, not only for sustainability, but also just in case, you never know. And other labs that might not have the resources to buy tips and bottles every time they get a new sample. So.
Okay, no, that's brilliant. Thank you. Great answer there. We're going to have one last question because we are completely out of time, but there's so many questions coming in. Martin, it's probably probably for you. Can you talk to anything about kind of data-driven approaches? If data-driven approaches are being used to identify inefficiencies in lab operations, so looking like a kind of a big picture scale, do you know if anything's being done in that way to kind of try and find out where we might be able to make savings?
Well, I'd say that the work that you just heard from is the, to be able to look at sort of the macro impacts of sustainable lab efforts. It's the initiatives that, like we just heard from Helena, in terms of trying to quantify these things that allows us to get data to inform ourselves. We know about energy consumption relatively well, but in terms of the trade-offs that both Helena and Christina spoke about, I think are why we need to investigate this area a bit more, because actually the uncertainty is what stumps us about knowing what the right thing to do is. People want to do the right thing, but then they want to have the certainty behind it. So in some areas, yes, we've got very good data in terms of our energy consumption when it's just, we use that piece of equipment uses this much energy, or a fume covered in ventilation systems. These are very more, and the data is out there and we have the data, and then it becomes about coming up with steps that we can take that reduce and measuring those and knowing that and continuing. But then the trickier stuff is actually what your grants are enabling us to understand. So I think just to put it all together as a last point, I think that ties it up. So yes, using data, but more needs to be studied, and would encourage the listeners to think about what questions remain and how they might be able to use the grants to learn more about those topics.
Yeah, absolutely. Yeah, thank you. We're gathering lots of data, which is brilliant. Okay, well, we're completely out of time. So sorry for running a little bit over, but I wanted to get through a few more of your questions. But I just want to say thank you to our wonderful guests today, Martin, Christina, who's had to disappear to another meeting, and Helena for joining us to share so much valuable information about supporting sustainability in labs. That's been really brilliant today. But thank you also to the audience for getting involved in the conversation. I can see you're all quite enthusiastic about this topic, which is lovely to see. And if you've been inspired to try out some of your own lab sustainability ideas, then as we've mentioned many times, the RSC Sustainable Laboratories grant is open for a second round now, and grants of up to £10,000 are available. So please do check out the links we've shared and have a think about if there's something that you can do in your lab to have a think about addressing one of the problems. But I think that's definitely all we've got time for. So from everyone here at Chemistry World, we look forward to seeing you again in a future Chemistry World webinar. Thank you very much and goodbye.